So to finish up our discussion on use case diagram, we're going to talk about activity diagrams, which are not use case diagrams, but they're frequently included in fully developed use case descriptions, because a fully developed use case description should adequately describe a particularly complicated use case. So these are diagrams that show us business processes, right? So they're going to show us all of the activities involved to complete some kind of task. So they depict the sequence of events to complete a task. For either from the perspective of the user or from within the system. So the syntax for an activity diagram, basically they're workflow diagrams. You may have seen something like this before, but basically you have an action or activity, which is sort of an oval. Then you have your flow, which is just an arrow. And then the initial node is a dot. And the final node is the target, right? Kind of looks like a bullseye, more or less. But that's the final node. You can also have decision nodes, which are a diamond. And then there are also joins and splits, which we'll talk about here in a little bit. But basically, your actions and activities are something that is performed for some specific business reason. You're going to name them with a verb and a noun. For example, get patient information. And activities can be further subdivided, but actions cannot. So object nodes represent the flow of information from one activity to another. And control flows model the execution paths. So there are 7 different types of control nodes. So an initial node is the beginning. The final node is the end. There's a final flow node, which stops execution path but allows other things to continue, right? So one particular task is done, but other tasks are going to be continuing concurrently. You have a decision node, which, or otherwise known as a guard condition, which describes, things that we have to do. Excuse me for 1 second. I forgot to plug my laptop in. There we go. All right, and then we have a merge node, which is going to rejoin anything that's been split, and a fork is where we split execution, right? So a merge is when 2 different execution paths come together, and a merge is when we split 2 execution paths, so 2 things can happen concurrently. And then we have a join node. So here's all of the different syntaxes. So it's a little more. This one's got a few more than my first slide had. This is from one of the textbooks that I had laying around. This is from I think a Wiley textbook, which is pretty good. Wiley has a good systems analysis and design for object-oriented, or UML. In any event, this is an example of some of the symbols that you'll see in activity diagrams. Here's an example activity diagram from one of those textbooks. So you can see here that we start with getting patient information. We have decisions that we're making. For example, is this a new patient? Is it an old patient? If it's a new patient, we're going to create the new patient, make a payment arrangement, create an appointment, and then we're done. If it's a old patient, we are going to see if they have any additional, new information. And if not, we're also going to check if they have any new payment arrangements, right? Did their insurance change? Then we're going to see if they want to create a new appointment, or if they need to cancel an appointment, or if they need to change an appointment. See, there's different ways that our actor may use the system when they are getting patient information. So that's a good example of a diagram. Sometimes we draw these in swim lanes. So a swim lane can assign responsibility to objects and individuals that actually perform the activity. Okay, so this is a swim lane. So we have different people that are doing things, right? So we have different parents doing something, right? We're getting ready for school in the morning. One parent is making a peanut butter and jelly sandwich, and the other one is getting their dessert and their drink, right? We're splitting responsibility, and these things are happening concurrently, but they're going to finish together to complete those activities. So that's an example of a swim lane diagram. So as far as creating these activity diagrams, first you want to set the scope of activities that are being modeled, identify the activities and connect them with data flows, identify any decisions that have to get made, any parallelism, in other words, things that are going to happen at the same time, which is important to consider parallelism, because if you think about it, parallelism allows things to be faster, right? If we can get 2 things done anything can be done concurrently, that reduces the amount of time to complete the entire activity. And that's really important in software engineering, right? We want to make sure in software engineering that computers can do a lot of stuff at the same time. So we want to make sure that we're thinking about ways that we can bifurcate those activities. And then we're going to draw our activity diagram. So as far as creating an activity, you're going to choose a business process or that you've identified previously, like the use cases that we talked about. You're going to find ones that are particularly complicated or that need to be more granularly explained. You're going to identify the activities that are used in the process. You're going to identify all of the flows and the nodes. You're going to identify any object flows and so forth, right? You're going to lay out your drawing, and you're going to diagram that process. And that's pretty much it. So diagrams, activity diagrams are pretty simple. You just got to follow the syntax that I talked about with those different symbols to show the activity. And again, the basis of it is you have a starting point and an ending point. In between, you've got execution paths, which can be joined or split. And then you have decision points where you're deciding what to do, and then you're doing some activity along the way. So that's it. So in this unit, I talked about how to do use case diagrams, how to brainstorm what the functional requirements are, which are our use cases. We talked about some different methods for doing that, like the brainstorming technique. We talked about event decomposition, which also covers temporal and state events in addition to our user events. And then I also talked about using the CRUD technique, but to be careful about the perfect technology assumption to make sure that we're not going overboard. And then finally, I talked about activity diagramming. I also talked about the fully developed use case diagram, which typically would contain an activity diagram, which is why we discuss it in this unit. And that's it. So if you have any questions, let me know. Thanks for watching.